Hi, in this video I'll show you how to work out this question taken from the Elementary Maths exam of 2014. Now let's look at the question. It says the diagram shows a triangular flower bed ABC on horizontal ground. AB is 4.6 meter, AC is 3.8 meter, and angle ACB is 78 degrees. Calculate part 1, the angle ABC, and part 2, the area of the flower bed. So we are given this diagram here. Two of the sides are given, and the angle here, which is a non-included angle, is also given. Since we are given two sides and non-included angle, we know we have to use the sine rule to find the angle asked for in part 1, the angle ABC. So let's write down the answer for part 1. Sine of angle ABC over the length of the side opposite, which is 3.8, is equal to sine the given angle here, 78 degrees, over the length of the side opposite, this angle 4.6. Cross multiplying, we'll get sine angle ABC. The 3.8 we bring up to multiply with the numerator on the other side. We get 3.8 sine 78 degrees over 4.6. Working this out will give us the value 0.8080. Therefore, the angle ABC is the inverse sine of this value. When we get this value in the calculator, just press the shift key, the sign key, and then the equal sign. That should give us the angle 53.904. degree. When rounded up to one decimal place, the answer is 53.9 degrees. In exam, your answers for angles should normally be given to one decimal place, unless otherwise stated. Now for part 2, we are asked to find the area of the flower bed. We can use the formula half AB sine C. That is, we need to know two sides and the angle between them. So we have to find this third angle first. So this second angle here, angle B, is 53.904. We should always use the more accurate figure in our working. So angle BAC (180) minus 78 minus 53.904. That will give us the value for 8.096. Now we can find the area of the flower bed. It's half multiplied by the two sides, 3.8 and 4.6. Sine the angle between them. Working this out should give us the value 6.50 meter square to 3 significant figures. Now let's look at part B. Let's first read the question. It says, the base of a vertical flagpole CM is at vertex C of the flower bed. So this is the flower bed here, and there's a vertical flagpole here, 6 meter tall. The flagpole is held in place by two cables, AM and BM, and CM is 6.0 meter. Part 1 show the AM is 7.10 meter, correct to 2 decimal place. Now, since the flagpole is given as being vertical, and these three lines here, AC, AB and CB are horizontal, so we know that the angle here must be 90 degrees. Similarly, the angle of this triangle BCM, the angle BCM must also be 90 degrees. So we have two right angle triangles here, the triangle ACM and the triangle BCM. And let's look at part 1. We have to show that AM is 7.10 meter. AM is the hypotenuse of this right angle triangle ACM. So since we know the two sides AC and MC, we can use Pythagoras theorem. So AM square is equal to the sum of squares of the other two sides, 3.8 meter square plus 6.0 meter square. So AM will be the square root of this sum. The sum of the square gives us the value 50.44. And when you find the square root, you will get a value 7.1021. When rounded up to 3 significant figures, you get the answer 7.10. Now for part 2, we are asked to find, given that BM is 6.95 meter, find the angle of elevation of M from B. I will first draw the right angle triangle BCM. So we have the triangle here, BCM. And we are asked to find the angle of elevation of M from B. That would be this angle here. And we know the length of MC to be 6 meters. And BM is 6.95 given in the question. So we can find the angle here by using sine. Let's call this angle X. So sine X is equal to opposite side over the hypotenuse, 6 divided by 6.95. That will give us the value 0.8633. So the angle X is the inverse sine of this value. We get the answer 59.69 degrees. Again, rounded up to one decimal place will give us the angle 59.7 degrees. Now for the final part, find the angle A and B, given which is the angle between the two cables. So looking at this diagram, it is this angle here. So looking at the triangle ABM, we already found the length of AM from B part 1. The length of AM is this value here, 7.1021. And we know the length of BM, which is given as 6.95 meters. So since we know three sides, we can find this angle. So the angle M here, or angle AMB, by using cosine rule, is the sum of the squares of the sides on both sides of the angle that we want to find. That is 7.1021 square plus 6.95 square minus the side opposite square divided by 2 times these two sides, 7.1021 multiplied by 6.95. That will give us the value 0.7859. So therefore, angle AMB is the inverse cosine of this value. That will give us 38.2 degrees. Again to 1 decimal place.